Thank you very much, Barbary, and welcome everyone. Thank you for joining us. Our webinar today will cover the use of digital twins in urban planning and AEC. I'm joined here today together with my colleagues, Micah Callow, Technical Director for AEC, and Jeff Taylor, Solution Engineer on the Imagery and Remote Sensing team. My name is Brooks Patrick. I'm the Global Sales Manager for Smart City Solutions at Esri. So today, Micah will first kick us off with a brief overview of digital twins at Esri, followed by Jeff, who will take us through the key steps behind data capture and the integration with your work. I'll then provide an overview of 3D across the ArcGIS technology stack before we take a deep dive into 5 case studies. Each of the 5 case studies will demonstrate how to approach your own digital twin, starting with a 3D base map. We'll wrap up with questions at the end, but please feel free to use the panel throughout the presentation to submit your questions. And with that, I will hand it over to you, Micah.
So we're going to start off a little bit with how this all connects to digital twins and what they actually are, right? So it's really important to get the definition out there. A digital twin is a virtual representation of the real world, including physical objects, processes, relationships, and behaviors. And it's really important to recognize that GIS creates digital twins of the natural and built environment and uniquely integrates a lot of different types of digital models. So what we're saying here is look, digital twins is a thing. It's a bit of a North Star kind of a marketing aspirational term that ultimately starts to build sci-fi representations of the world. GIS has been playing a role in this capacity for a very long time. And the reason why we are so well suited in this is because it's all about location. Location is what connects everything and everybody. So therefore, GIS is definitely a player in the role of building digital twins. So when we look at digital twins and how it's kind of transforming what we do, we start to think about ways that Esri is already playing in the realm of digital twins. So we do a lot of landscape information modeling. We've been doing this for many, many years and playing a big role, kind of bringing together understanding of the landscape, topographic, and environmental world around us. BIM is a fairly new area, which we'll talk a little bit more about later, and it starts to bring the facilities and the plants and the structures and the built information into the world of geospatial. Network information modeling is an understanding at scale of the network of something connected, power lines, utilities, water, gas, etc. So it's this ability to kind of bring together and stitch together an understanding of the entire network. And then when we really talk at scale, we're starting to talk at city scale. So really starting to understand a city for all different purposes and capacities. And that's what we're really going to dive into more today. So what are the drivers for looking at this in this way and bringing it up from a digital twin perspective? Well, there's kind of a high cost of reoccurring plan updates. So every time we have to rethink something, we're starting over. And that starting over is costing us a lot of money and a lot of time and effort that people can be used to do other things. We want to increase efficiency overall. We're looking towards removing these silos. Every time we move from plan, design, build, operate, we're almost starting over in a lot of ways. And then even in the operate phase, there's a bunch of micro processes that happen that also build up silos. So the digital twin, thinking more strategically, starts to pull us out of those silos. And that allows to create better accountability and transparency towards our goals and demonstrate sustainability. So not just say that we're sustainable, but actually demonstrate that sustainability between the built and natural world. And it really highlights this insufficient access to the current GIS data. So opening up GIS to this world starts to show how important GIS data is to this process of building a digital twin. And that allows us to maximize and look at people and data and technology, right? So we want to maximize that investment, that money that we put into this, especially from the people perspective, because the more we're doing things and making things more complicated, the less we're getting out of our people, and people are the ultimate commodity in actually making this stuff work. And then that allows us to start to think about things a little bit differently, like desire for more diverse community representation and simplifying communications to ensure that we're doing what we're supposed to be doing. So these are all things and drivers for why we look at digital twins in between the planning and AEC space. So GIS interconnects and integrates. So when we start to talk about what GIS does, it's the things that we've been doing for a long time. Data capture and integration, that's bringing together the information and managing it, especially the spatial and the data modeling type stuff. Real-time and visualization. So we've been visualizing information for a very long time. That's been the kind of core of Esri. But we're starting to bring in real information in order to understand what's happening now in real time. And that allows us to start to think about ways that we analyze and predict, not show what's already happened, but predict what is going to happen and simulate things. So run scenarios, test changes, and see what the impacts are going to be, which ultimately leads that sustainability goal. And then last but not least, we've got to finish the marathon. We don't want to run all the way up to the finish line and stand there and stare at it. We need the ability to share and collaborate with stakeholders that don't necessarily understand the technology and the tech behind what we're talking about. So it needs to be simple and easy to collaborate and share. So today we're going to focus on two specific areas, and we're going to dive deep into the data capture and integration and the real-time or the visualization aspects of the digital twin.
It's important to understand the 3D production process from data capture to integration. No matter what data format you plan to work with, ArcGIS integrates all types of data, from 3D point clouds and 3D mesh to satellite to ortho imagery and even oriented imagery. You can take advantage of your imagery and remote sensing data to develop this 3D base map foundation of your digital twin. So let's go through the three main challenges to creating a 3D base map and the solutions to ensure your success: obtaining data, processing data, and disseminating your foundational 3D base map data. Which leads us to our first challenge. Where can I successfully obtain this source data? Well, ArcGIS includes an enormous amount of data from ArcGIS Online. Base maps and imagery, a whole living atlas of thousands and thousands of layers that can have direct access to and integrate into your own work. And also users share millions and millions of layers and data sets openly so that other users can leverage them. This might be an ideal location to start for you. So as we just discussed, you can take advantage of ready-to-use content in the Esri Living Atlas that may be available for your study area. But if you're building your digital twin model for the first time, or simply looking to update an existing model, your existing data or publicly available open dataset sources are an excellent foundation. If you still have that hard drive from an imagery or LiDAR collection a few years back, it's time to brush those cobwebs off. But you can also take advantage of open data from state, local, and national government agencies, such as the U.S. Geological Survey's 3D elevation program that collects LiDAR point cloud data and provides those free of cost. Additionally, you can purchase and download select 3D city models that have already been produced from Esri business partners on the ArcGIS marketplace. And there's also many business partners with catalogs of existing imagery, point clouds, 3D mesh data, etc., that can be purchased for 3D base map production purposes. And on an additional note, agencies such as the U.S. Department of Agriculture also have national aerial imagery programs and provide the data free of cost, just like the 3D elevation program. However, if you need a higher resolution version, just contact us at Esri about the load and go premium imagery content offering. This leads us to our next 3D base maps challenge. Challenge number 2, processing data. The need to manually digitize and create content are long gone. With ArcGIS Pro and the ArcGIS imagery GeoAI collections, you can extract value from your imagery, such as building footprints using one of Esri's pre-trained neural network models, enabling you to detect more complex features like these transmission lines shown on the slide. Additionally, you can take advantage of ArcGIS Pro and the 3D base map solution to help streamline the workflow of classifying your LiDAR data and extracting your 3D base map data for your digital twin. Beginning with your existing LiDAR point cloud data, automatically detecting and classifying features, to extracting and supporting hybrid visualizations of your data, or simply extracting the schematic capabilities and visualizations for 3D models. ArcGIS Pro and the 3D base map solution can help your organization go from zero to hero for your digital twin. And this brings us to the next and final 3D base maps challenge. Challenge number 3, disseminating data. The question we're constantly asked is, now that I have 3D data, how can users across my agency, partners, clients, or the general public take full advantage of it? By sharing data to the cloud on ArcGIS Online or ArcGIS Enterprise, users can access your 3D base map data leveraging ArcGIS Pro, web-based applications, or even devices. Gone are the days of 3D data only being accessible on a single machine or hard drive. Publishing 3D data to ArcGIS Online or Enterprise enables sharing across your organization or to the general public where everyone can interact. And for those of you that constantly are having to share source imagery, 3D data to third parties, you can take advantage of the cloud-based data dissemination solutions, allowing anyone to select and download data files of interest.
Thanks, Jeff. 3D has really seen huge advancements in capability across ArcGIS. And as you've seen, you're able to apply 3D GIS data to the same WebGIS deployment pattern that you've been accustomed to for 2D mapping. For example, this means you can publish one 3D layer and then share and use that single layer throughout your organization, either on ArcGIS Online or on your own private cloud, through desktop tools or through the web browser, or across many apps or projects. In September 2020, Esri announced an exciting acquisition of InFrames. This is a technology company that develops Shore. Shore is an industry-leading 3D surface reconstruction software, and this is really enabling a fusion of imagery with 3D GIS and provides an end-to-end process for seamlessly capturing, analyzing 3D data from aerial drones and from ground-based sensors. So reality capture data at a massive scale is bringing textured 3D base maps to ArcGIS that can be easily managed and updated as new imagery continues to be collected. Textured mesh complements the more feature-based 3D base maps, both of which represent the replication of the existing built environment. On the left, you can see 3D buildings as discrete features. Esri has released those machine learning solutions, deep learning, to extract these building features. And for 3D mesh, shown here on the right, numerous Esri business partners in the imagery space, such as Nearmap and Aerometrics, offer full libraries that cover a majority of the US major cities and their suburbs, along with Canada and Australia. Behind the scenes, we have some basic ingredients that make up the main components of our 3D mapping platform. Scene layers allow users to author and visualize large volumes of 3D content, and to combine this 3D content with other data types in visualizations and analysis. Scene layers can be combined with feature layers, imagery layers, and then displayed and explored with high performance by a variety of out-of-the-box applications that Esri builds, as well as your own custom applications that you might want to build. So together, scene layers, feature layers, and imagery make up the primary components for content creation, editing, and authoring, as well as data management. Esri also has APIs and SDKs built and designed to allow developers to customize ArcGIS for their workflows. The ArcGIS JavaScript API is both a 2D and 3D API for building custom apps and widgets for the browser. For example, the standard scene viewer is built with the JavaScript API. The ArcGIS Runtime SDKs are a set of libraries for native application support for both 3D and 2D. And to give you another example, ArcGIS Earth is built with the ArcGIS Runtime. We've also recently released our developer beta of the ArcGIS Maps SDK for both Unity and Unreal Engine, the two leading game engines. Both Unity and Unreal game engines can bring modern, immersive, and interactive visualizations to both desktop as well as mobile applications. Esri has a suite of out-of-the-box applications for both planning and AEC. ArcGIS Urban is our latest application, which sits among other tools that you may already be familiar with, like ArcGIS Pro and City Engine. ArcGIS Urban is a scenario planning software. It's web-based, and it leverages that 3D base map to support the planning and urban design initiatives that you may have. We'll take a look at Urban in a bit more detail in the upcoming examples. We have a few additional applications that sit together with these, namely Business Analyst and a new upcoming application that I believe Micah will give you a short preview of called GeoBIM, for this offering cloud-to-cloud integration with Autodesk's BIM 360. And beyond these back office applications, we have a group of what we'd call front office applications that empower additional workflows to support stakeholder engagement and presentations. So from ArcGIS Hub for website creation and open data hosting, to app builders such as Experience Builder and Story Maps, to survey tools and plugins like the Adobe Suite plugin here on the slide. So now what we'll do is transition and dive into a couple of demonstrations to highlight the different ways to approach your own digital twin, starting with the 3D base map. And feel free to steal these patterns. The 5 examples we chose will really highlight a sort of complexity spectrum from the most simple, cost-effective, to the more complex and higher resolutions. So our first example today, we'll start with an approach utilizing the 3D base map solution from Esri along with existing data. The city of Des Moines used a 3D base map solution to create a 3D city model in order to assess and protect the viewshed to the Capitol building, while still encouraging development throughout the city. So this digital twin helped Des Moines adopt a viewshed corridor zoning ordinance to guide the new master plan development in the East Village of the city. So we'll take a look at this, but we'll also start from the very beginning with the basics. So the city of Des Moines, like many cities across the US, have a rich set of building footprints. Building footprints are often created as outlines of structures or blocks of structures. And by using Esri's 3D base map solution, the city was able to leverage their LiDAR data in order to segment the buildings by roof lines and extract height. So what we're looking at here is a web scene. It's similar to a web map, which was just shown, but it enables you to use both 2D and 3D layers and combine them together in the same visualization. A detailed ground elevation layer was also automatically generated and used to enhance the existing elevation that Esri provides for the entire world. So if buildings are classified in the LiDAR, or if the LiDAR is dense enough, the 3D base map solution will also allow you to extract the building footprints as well, which Jeff will get into in a bit. You can also add data to your web scene, so either from searching ArcGIS online or directly from your enterprise layers hosted in your own cloud. So in this example, I'll add an enterprise layer that represents a dynamic feed of projects and really capital improvement projects throughout the city. This layer had existing symbology, so the scene inherits that, and it drapes the features to the surface. The layer will also include any pop-ups as well that might have been configured on the layer. Attributes like project name, estimated start dates, etc. And as you can see, the symbology in a web scene can be formatted based on any field in the layer. And in this case, we're using the category field, but any could be used. If we go into the options, you can also change things like the style and add labels. For example, we can add a label here showing the estimated construction start date and add a call out to make sure that the label is not blocked by any structures that may be in the 3D scene. So symbology that has been applied to points, lines, or polygon feature layers in a web scene also applies when you use a different type of 3D base map. For example, a 3D mesh. So in this case, I'll search for a 3D mesh within my organization and add it to my scene. So this 3D mesh comes from our partner Nearmap. Nearmap offers a library of 3D textured mesh for nearly every large metropolitan area in the US. And as you can see, once the mesh is added to the scene, the layer with our projects, it drapes seamlessly to the surface of the mesh. This is really exciting as a capability because it means you don't need to worry about attributing the mesh itself, at least not directly, but rather you can use other layers draped to the mesh in order to construct your scene. So if we wanted to know what this project is, we can click on the mesh, which launches the default pop-up in the layer. So this is really exciting and allows for a lot of flexibility. And this 3D base map can be used in a wide range of workflows and applications, such as ArcGIS Urban, which we'll be going through today. ArcGIS Urban, as I mentioned, is a 3D scenario planning software, and we designed it to work with any of these 3D base map types, alongside other layers such as zoning and land use, in order for you to test build-out scenarios. So in this case, the city wanted to ensure that changes to zoning didn't block important views to the Capitol building. So we can visualize zoning envelopes to help better understand height constraints, and then by allocating new building types to the plan area, we can further represent the potential change. And then using one of the tools that we have in Urban, in this case, the line of sight tool, we can simulate the views from the Capitol Dome to the river, as you can see here. And the proposed change does block a number of these sight lines shown here in red. So no doubt we're going to have to lower the buildings a little bit more to preserve that view. And so as you've no doubt learned in today's presentation so far, LiDAR can be a great starting point when it comes to your first 3D base map, like the one you see in this scene. But even more layers can be extracted when the LiDAR is high enough point density, like power lines, trees, and I will now hand it over to you now, Jeff, to talk about this further in the next example.
Thank you, Brooks. So next we're going to talk about how you can build that foundational base map, as was done for the nation of Grenada. And we're going to take advantage of GeoAI, ArcGIS Pro, automate all these processes leveraging imagery and LiDAR data, and show multiple types of digital twins that can be created based on the data your organization may have access to. So let's kick this off. Let's take a trip to Grenada in our 3D web scene. We can turn on the default Esri world base map imagery for additional visual context. And narrow our zoom to the capital of Grenada, St. George's. To improve on the default 3D elevation, we can switch to Grenada's elevation service derived from their recent LiDAR collection. But by default, Esri provides a rich elevation that you could use for your base map. We can also add Grenada's recent high-resolution imagery. And let's see how Grenada was able to leverage this imagery to extract a building footprint inventory of the entire nation. Esri has produced many pre-trained deep learning models that can be accessed on the Living Atlas. Taking advantage of one of these models pre-trained on building footprints covering the entire United States, Grenada was able to deploy this model on their ortho imagery using the detect objects using deep learning geoprocessing tool and extract building footprint polygons for the entire nation. The building footprints could then be published to ArcGIS online, and a simple 3D extrusion applied in the 3D web scene for your initial 3D base map. In ArcGIS Pro, LiDAR could then be classified using an automated process resulting in intelligent 3D base map data. Once processed, you'll note the classified features. The data can then be published to ArcGIS Online and added to a 3D web scene. And by only enabling the LiDAR points with classification codes other than ground or water or noise, the next iteration of Grenada's 3D base map was complete. In ArcGIS Pro, the LiDAR could also be colorized using ortho imagery for added realism, just as it was classified. And you can see how amazing the red, green, and blue values can be transferred directly to the point clouds for another iteration of your base map. And in order to extract 3D features from LiDAR data, the 3D base map solution was used. This solution is a task-based workflow that guides users through processes such as extracting building footprints from LiDAR data, creating 3D buildings using the LiDAR and the extracted footprints, and even detecting and extracting a vegetation inventory. This 3D data was added to the web scene and used for different visualization styles, from a schematic look and feel to a more realistic fusion with the colorized LiDAR data, to even a stylized sketch design. And using Esri's 3D flood impact analysis solution, the ability to assess potential risk to sea level rise or storm surge was made possible. But before we leave Granada, let's catch a sporting event. Or stay at one of many of the island's resorts. And last but not least, catch our flight to our next case study destination. Back to you, Brooks.
Yeah, thanks, Jeff. Really, all of those images look like watercolors. Our next example takes us to the city of Fullerton, California. Many use cases require a textured model of the city in order to better communicate planning scenarios and obtain buy-in, often for some contentious decisions around housing density. So in this next example, we'll demonstrate how a 3D mesh from our partner Nearmap can provide citywide context for ongoing planning initiatives using ArcGIS Urban. So let's go ahead and dive in. ArcGIS Urban supports scenario planning utilizing both land use and zoning codes. So you can sort of think of it as a digital twin of local regulations. Here we also have a 3D mesh from our partner Nearmap, which is perfect if you're looking for a textured 3D base map for an entire city or county or even region that you may be working in. This is the existing general plan land use for downtown Fullerton. And with ArcGIS Urban, you can visualize the existing land use and test alternative scenarios by proposing future land use. So in this example, we're going to be exploring the city's rail district specific plan, which is just west of the downtown. This plan is looking to convert existing largely industrial land uses to a medium to high-rise mixed use. So with a paint tool in the land use plan, we can select the land use type and then apply that to the parcels as the tool selects the parcels that overlap. And this will create new land use district polygons at the same extent of those parcels. So this will make it possible to create many design options to explore many different outcomes and decisions. But for now, what we're going to be doing is taking a look at the specific plan of this site and create some scenarios for the rail district. Regulatory models for zoning are also copied from the existing conditions whenever a new plan is created. And the existing zoning information is made available within that study area. In this example, the city is aiming to build more housing near the downtown rail station, and most of these scenarios will fall within a 5 to 10 minute walk of that station. So within the plan area itself, we can use the existing zones as reference, and we can propose new zones, as you can see in this scenario. So each zone type in Urban is created using a common framework of parameters, such as FAR, maximum height, number of units, or maximum coverage. Then, based on this information, development models can be used to test the build out of the parcels under these new zoning codes. Here we can see a lot of office and residential mixed-use buildings that have been proposed throughout the plan. So each building is made up of space uses. In this example, we see retail on the ground floor with a mix of apartments above, both affordable as well as typical multifamily. So let's go ahead and create a new space use type based on an existing one to represent some larger apartments, for example. We can open up the space use type manager and open residential multifamily. And then we'll choose to create a duplicate of that space use type and rename that to residential multifamily, but with larger apartments. And we can also give it a label. In this case, we'll call it lofts, and choose a new color. So once you're finished, we can actually hit done and adjust the space uses underlying metrics to drive the capacity metrics downstream used in the evaluation of any scenarios that we might build. So now that we have our new space use, we can select a couple of parcels and create a new building type. So we'll pick this intersection right here, very close to downtown still. So to create a new building type, after selecting the parcels, you would actually go back to the development panel and hit modify, and then we'll hit the plus button, similar to space uses. So first step is to add a new building part, and we'll give that new part our larger apartment space use type. And we can also add a part below that for some ground floor retail. And then we can set the residential part with a range of floors from 1 to 5 to give it a bit of flexibility depending on what the code allows. And we can finally give it a name, in this case, the medium density apartment lofts, for example. There are a lot of additional options to adjust the minimum or maximum footprint size, as well as which side of the parcel the building will prioritize. We'll just use the defaults for this example. So now that we've created it, we can now apply it to the selected parcels. And as you can see, we have quite a few building types available in the list, and you can adjust the defaults that appear in that list across all plans. So once you've applied them, now we can take a look at the space uses that are represented, but also look at the downstream capacity metrics. And that expanded capacity dashboard now shows parking, trip generation, energy, water use, and we're actually releasing later this summer the ability to customize your own metrics in this dashboard as well. They can all be exported to Excel and used as input to any existing evaluation models or feasibility reports that may already be in use. So as you can see, the 3D base map, the 3D mesh base map from Nearmap can make a really big difference in how we understand those plans in context. So a textured city model is ideal for communicating out some important concepts like building height of potential development relative to what exists today. Our fourth example will take us to the city of Centennial, Colorado. The challenge being addressed here in this example is to provide context and 3D visualization for the proposed redevelopment of a large big box site within a very important commercial corridor for the city. So our partner here is Aerometrics, and they provide super high resolution 3D mesh for project areas within the city, enabling you to test new development proposals and communicate effectively with stakeholders. So let's take a look at this example. So here you can see right off the bat the extent of the project corridor that was flown by helicopter and captured at a very high resolution. This corridor is an important commercial center for the city. And as you can see, there's an opportunity to further densify the location with more opportunities for example, medium density housing. And the proposed changes that we're looking at here for this location would really only affect the farthest north and south areas of the center, including the Macy's building, and also at the other end, looking at the Sears building. Otherwise, the majority of the center would remain unchanged, making it very important to have that high resolution mesh next to what we're proposing. So with Urban, we can visualize the site with the help of Aerometrics 3D mesh model and then design how the location would be changed. So we can go ahead and take a look here at the South Glen example plan, which was designed as a mixed use center, so a live-work approach. And as you can see, as I turn on the space use coloration, most of the development would go towards expanding the residential units across the southern end of the site. And this would continue the public space running through the development. And so with Urban, we can make slight alterations to the building types being used in this scenario. So for these residential buildings shown in yellow at the end of this corridor, we can actually experiment with a change to the number of floors, for example. So by opening up that building type, rather than 3 floors, well, 2 to 3 floors, we can test the impact of adding a couple more. So here we can add up to 5, 4 to 5, which would actually better complement the residential structures that are already built nearby and that can be seen in the mesh. The scenarios can then be scored. I mean, we can look at financial feasibility from a financial perspective, or to find adequate yield to meet the requirements of the developer or the city, or we can just look at how each scenario may perform from a regulatory perspective. Urban has a number of different out-of-the-box tools. You saw just briefly the line of sight tool in our first example. There's also a slice tool, which will literally slice through anything in the scene, through the 3D mesh, through any buildings that might be there, anything that might be in the scene. And this is a great way to assess the overall proposal. It can actually be rotated and moved into position in order to take different views of that model. You can take section images, and this will give us different views that we may not always be able to see, like underground structures that may exist, whether it's underground parking or utility lines. There's obviously a lot of room to really grow out this site, so we'd probably put a lot of contextual data into it. And Micah will actually get to that in his next example, how much you can literally put into this scene. But with Urban's dashboard, you can get the readout of the scenario itself, as discussed in the previous example, and then look at that breakdown relating to units and jobs. So now we've opened a project in Urban. Projects in Urban allow us to look at the current developments at a city level, but also their individual status. So if there are any 3D models available for the proposed development, we're able to insert those into ArcGIS Urban, and all of the analysis tools can also be used to assess that proposal within its context in Urban. So in this case, we're looking at some proposed apartments for the current Sears location that we were looking at just a second ago. And as you can see, they resemble those 5-story proposed height changes that we tested earlier. So adding external models into a high-resolution 3D mesh base map can help us better understand that relationship between what's being proposed on one hand and then what the existing built environment looks like on the other. There are also a number of different tools that we can use to sketch that proposal. So you don't actually have to have an external 3D model. You can sketch in here as well. There's also a library of models such as trees. And in this case, we can place a few proposed trees and experiment with how enclosed we would like to make this public space next to the proposed apartments. And as you can see, we can scale each of these models, rotate the trees, and we also have different external lighting fixtures as well as other outdoor street furniture that you might want to use in your scene to augment that external model or your sketch. This content within the scenario can then be published. It can then be used publicly within community meetings or within applications like the game engine walkthrough experience that we showed a little bit earlier in the example. For our last example, I'm going to now hand it over to you, Micah.
All right, so for our last example, we're going to dive a little bit into some of the details. So when we've been talking at the high level, some planning, some simple ways to get started, quick capabilities to bring together a good visualization and an understanding of an environment at scale. So that's starting to characterize our site or our city at scale. Well, when we start to talk about what is the future, we really want to start to dive into some specific details, right? So this is that intersection of GIS and BIM, or design and engineering, planning, and geospatial. So in this example, we're kind of making up a location. It's kind of sensitive because most BIM information is sensitive and hard to share. But the main challenges are we kind of want to represent a digital representation of an area that we're designing and developing. And we need to keep that information fresh and connected to our geospatial environment so we can communicate it to the stakeholders. So we need to basically be able to bring in multiple 3D objects and start to really visualize in detail this environment. So this is where our partnership between Esri and Autodesk really comes into play. In this scenario, we're working in ArcGIS Pro, and now in ArcGIS Pro, we have the ability through the BIM connector, the ability to connect directly through to Autodesk Construction Cloud, or what was previously known as BIM 360. And we can bring in all kinds of information. In this case, we're looking at some civil 3D drawings. The nice thing here too is that we see the actual civil 3D drawing as it was intended to be drawn, not just as a simple CAD file. And we can visualize that information in both 2D and in 3D and interrogate that information in our ArcGIS Pro environment. So this allows us to kind of start to think about things at scale, start to bring things together that are coming from the design and engineering teams, and keep that information fresh because we're pulling it from the source. But since this is a 3D conversation, let's talk a little bit about starting to bring that together in 3D. So now we can start to visualize that information in a 3D scene in ArcGIS Pro, which allows us to start to bring in other information that surrounds our project site. In this case, a bit of a brown field that we're developing a structure on. But we don't just want to look at the pretty building sitting in a structure. We need to start to understand how the building itself interacts with the world around it. So we want to bring in some of the Revit information. We want to bring in some of that civil 3D information we were looking at earlier. We want to build a general representation of this specific site. So effectively, what these become are building blocks towards the bigger pictures that you've been seeing today. So these components are going to start to really supercharge what we're looking at, and over time, we're going to start to see these things really scale out as we bring more information together in this way. So as you can see, we can see under the surface and above the surface, which allows us to understand what the interface looks like between the building itself and the infrastructure that's going to support that building around it. But it's not just something that we want to lock away in ArcGIS Pro. We need the ability to share it and collaborate. So in this case, we're going to share it out as a web scene, publish it just like we do any other web scene data from ArcGIS Pro into our ArcGIS online environment. So once we share that out, it becomes accessible to the group that's working on this project. And this group includes more than just the GIS professional. This is beginning to include the actual design and engineering teams. And by doing that, we're starting to build this capability, which is coming out later this year in a product called ArcGIS GeoBIM, which is what you're looking at an earlier prototype here of. And this allows us to connect between that scene we created and the actual BIM 360 documentation live. So we've created this intelligent connection between those two, effectively the project and the scene layer, and allows us to maintain that connection through the design process. So we're not talking about just simply converting the data and bringing it in as for a one-time shot. We're physically connecting these two models and accessing anything that's available in the BIM 360 or Autodesk Construction Cloud environment. And this is really powerful when we start to talk about design coordination and impact changes. And then future reference, when we start to talk about operating this structure, we can always have access to that information as it was originally intended. And we don't have to go through and individually create that one-to-one hyperlinking type connection. This is an intelligent connector that exists between these two cloud environments that's going to be very powerful, I think.
Thank you, Micah. I'll take back the screen from here. And I'll go ahead and summarize some of the key points that you can walk away with today. If you're looking for new ways to enhance the urban planning at your city or support the design and construction process within your projects, as Micah had just shown you. And the first point is really, you should get started and really start with by identifying and connecting to open data sources. Like the US Coastal LiDAR program. Also, many entire states have procured and opened up high-resolution LiDAR data sets, like the state of Connecticut, for one. And you can also start by publishing your existing GIS and 3D city models to the web if you already have them to support visualization and sharing. And all of the applications that we showed today are available to you. Obviously, some are coming a little bit later in the year, but most are available, and I recommend starting with an evaluation copy. We also have a 3D launch kit training available, and also great business partners that you can work with to help you get started as well. So like Micah mentioned, if you're still not sure where to begin, please feel free to contact us directly, and we can also help out. Now, we'll open it up for questions from the audience, and in case you also missed our last poll, you can also schedule a 30-minute meeting to walk through your own data with this link on the slide as well. But with that, I'll hand it over to you, Barbary, for the Q&A.
Yeah, absolutely. So we've got several questions. Continue to send those in, folks. First one, I believe this is for you, Micah. Where does Indoors and Utility Network Manager fit within the digital twin offering with Esri?
When you start to talk about things like utility network and kind of indoors, it's basically supporting what you're trying to accomplish with your digital twin, right? So is your digital twin an urban planning kind of representation? Are you trying to manage utilities? Are you trying to manage intersection of those things and how they impact other things that are going on? I think the idea behind a digital twin is it's what is the real business problem we're trying to solve, and then putting in the appropriate tools. And sometimes that's going to go even well beyond Esri, right? So sometimes Esri is going to be a player in that conversation, and there might be other things coming in from cloud hosting to real-time sensors, et cetera. So utility network and indoors are just mechanisms to represent and understand the world around us.
Excellent. So next question on our list is, how do you drape that polygon color over the mesh? Is it possible on a regular multi-patch building?
Yeah, I could take that. With multi-patch buildings, they're discrete features, and whenever you publish these buildings as a scene layer, what actually gets published with them is the 3D, but also a companion layer, which is a feature layer that holds all of the attributed information and can be updated obviously more rapidly than you can a 3D cached file. So all of the attributions within those scene layers that are discrete buildings are kept within this feature layer that acts as a companion. So if you wanted to actually symbolize other polygons on those 3D buildings, you would actually have to represent those attributes within that companion layer that can then be used to visualize. So let's say you wanted to visualize, I don't know, let's see, how efficient a building is at heating itself. Then that would be an attribute on that companion layer, and then the symbology would know to visualize the color ramp accordingly, and it could be updated quite frequently as well. More so than the building itself. The 3D building doesn't change, right? Once you build a building, it doesn't really go anywhere, but the attributes within it can be altered. When it comes to the mesh, once you publish that 3D mesh, that mesh acts almost like a surface. And so what you're going to be able to do is actually use your feature layers, essentially a companion, like we were talking about with the discrete building. But those feature layers can be used depending on what you're trying to represent. So you could actually use the same one on a mesh and visualize the mesh based on that coloration of how weather resistant the building is, et cetera. So they're a little bit different, but they use the same concept of attribution through feature layer.
Great. So our next question is for you, Jeff. What steps are required to export a classified LiDAR as a web layer?
So I think we'll lump that in. There's a few questions on LiDAR. I'd like to kind of talk through those all at once, starting from the ground up and then sharing it. So the first question was more related to BIM and facilities. I'm going to scan my building. I might have a SLAM scanner, a standalone scanner, something else. Most of the scanners actually, if they're really good, get about 2 centimeters accuracy. Typically, you can even decimate, which is to reduce the point numbers in that scan before you work with it. So if you're creating your digital twin from an interior scan, you would take it into Revit to be able to process it in BIM, for example, for your models to be used in that whole AEC workspace. Beyond that, when you're starting to work with your city, county, or town, or just an urban area, the 3D base map solution and the LiDAR classification tools support anywhere from sub 1 meter, probably like 2.5 feet or less in the point spacing, is really where you want to have your density of your LiDAR. And those work very well in classifying that point cloud. So the question that we had was, I have my classified LiDAR now that I've classified in ArcGIS Pro or another solution. I want to share it. Well, in ArcGIS Pro, you can select the visual of just seeing the classified point cloud first before you export it, and run a tool called Share Point Cloud Scene Layer Package, or Create Point Cloud Scene Layer Package. And then you can then generate that scene layer package, which is multidimensional, so it loads quickly on the web. And people inside of your organization, on your enterprise, or outside of it can all access and use that. And the size is very small in those. I mean, when you talk about compressed LiDAR versus scene layer packages, they're about the same. And the costs annually for towns or where counties can be a few $100s to about $1,000 a year just to store a massively dense point cloud on the web.
Excellent.
Yeah, maybe,
Lots of great
maybe just
information.
quickly add as well. We publicly share all of the storage consumption rates if you're interested in using the Esri cloud called ArcGIS Online. And like Jeff mentioned, all 3D doesn't consume much storage. Parcels consume more storage than 3D because they're calculated at a different rate. So feel free to just look at it up on our website, and you get a complete readout of the consumption.
That's great. Micah, for you, what is Esri's solution for creating a collaborative environment that allows users, CAD and et cetera, to access data stored within GIS? And are there any plans to help integrate Bentley and other systems?
Right now, the solution I showed was a new product that's coming to the market later this year in the fall called ArcGIS GeoBIM. And that's an integration between the Autodesk Construction Cloud and ArcGIS Pro. With our partnership with Autodesk, that's where our primary focus is right now, and which is what you also saw in our ability to connect from Pro directly to the BIM3 or Autodesk Construction Cloud environment. That's where we're focusing our attention effectively towards the end of this year, and it's going to be a big release for us with ArcGIS GeoBIM. It really does start to open up that intelligent connection between the two. We're also moving towards support for IFC in ArcGIS Pro, which is kind of a bit of the open source approach to BIM, and so I think that'll be a big game changer, especially we see it throughout Europe and APAC and a little bit in the US. And then through other methods, we use tools like FME. We leverage those for dealing with the wide variety of tools and solutions that are out there that are creating 3D models in from a lot of different angles, not just the traditional design, engineering, and planning angles. We're starting to see new things come up. And including that, I guess I'd mention that we've also started to really go down the road of gaming engine integration, because people are beginning to bring geospatial into these virtual representation worlds that are building their own approach to digital twin. So we try to play in as many angles as we can. For obvious reasons, there's certain ones that we go further down and deeper into than others.
Awesome. Someone would also like to know what tool you guys used in Pro to view the BIM model, and do they need a separate license to use that tool?
No, the tool we used in Pro to view the BIM model itself, the first part of the demonstration that I did, is effectively just the BIM connector. It's under, when you go to add data, there's a BIM connector, and you establish the connection to the Autodesk Construction Cloud or BIM 360 environment, in which case you'll need credentials in that environment and access to a project to see that data. And you can bring it straight in, and or you could just have the BIM files and be able to read them into Pro as well. So there's really two avenues that you could get to that BIM information and read it directly in. From there, we create what is called building scene layers from that data, and that allows us to publish it to the web and bring it into these 3D environments.
Awesome. Well, thank you, gentlemen. We are actually a couple of minutes over time. So many more great questions, folks. So just hang tight. We will share those with the talented guys here, and they'll get back to you personally. Appreciate you spending your time with us today. Our webinar is archived, so keep an eye on your inbox for your on-demand recording as well as your attendance certificate. We appreciate your opinions on the brief survey, and if you missed one of those opportunities for a request to learn more, those are also on the survey, so you still have one more chance to get that information to the guys. So thanks, Brooks, Jeff, Micah. We really appreciate you sharing your expertise today. Appreciate Ben for his support as well. We hope you all will join us for more geospatial webinars. Have a great day. Tell a friend about Esri and Directions Magazine. Thanks, everybody.